Hello, welcome to our first tutorial on second chapter, force and momentum. So we are going to start with few examples. So let us begin. First example is a person walking on a sand and we can see the footprints of him on this sand. Second example is a nail is being hit by a hammer and the nail goes into the block. Third example, a man is pushing a car and man is pushing a pram. And last but not the least, the mummies. So we are going to start with our first topic called as Newton's first law. In Newton's first law, we are having these two examples. One is a mummy. This state is a rest position and this state is a motion. It's a state of motion and this is a state of rest. So let us first define what is meant by Newton's first law. As we know, Newton's first law says that the body remains at rest. It will remain at rest or at uniform motion unless and until some unbalanced force acts on it. The body will not be if it is in motion and if it is at rest, it will move from one place to another in rest state, and in motion it can, if it is a car, if it is a moving with constant velocity, it will decrease its velocity. So these two conditions are applicable. Okay, so what we want to say is that the body will change its states when some force acts on it. So just see the definition. A body continues in its state of rest or of uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. Meaning to say, एक ऑब्जेक्ट जैसे ममीज, दूसरा एग्जाम्पल है वो अर्थ एंड मून का. तो ममीज जो है वो उसी जगह पे जहाँ पे रखी गई है वो सालों तक उसी जगह पे रहती है. क्यों? क्योंकि उन पे कोई फोर्स एक्ट नहीं होता, इसीलिए वो वैसी की वैसी ही हमें अगर हम लोग ढूंढते हैं तो हमें मिल जाती है. सो ये जो एग्जांपल आता है स्टेट ऑफ रेस्ट का. और अभी अर्थ एंड मून का देखिए तो अर्थ जो है वो सन को रिवॉल्व कर रहा है और मून जो है वो अर्थ को रिवॉल्व कर रहा है. तो इन दैट केस दोनों का जो मोशन है वो चल रहा है, वो कहीं रुक नहीं रहा है. क्यों? क्योंकि उनके बीच में कोई फोर्स एक्ट नहीं हो रहा है, इसीलिए उसका जो मोशन है वो कंटिन्यूसली चल ही रहा है. तो इस तरह के मोशन को, इस तरह के स्टेट्स को हम लोग क्या बोलते हैं? न्यूटन्स फर्स्ट लॉ. सो न्यूटन्स फर्स्ट लॉ क्या बोलता है? बॉडी कंटिन्यूज इन इट्स स्टेट ऑफ रेस्ट, मतलब वो रेस्ट में ही रहेगा, और ऑफ यूनिफॉर्म मोशन इन अ स्ट्रेट लाइन अनलेस इट इज कंपेल्ड टू चेंज दैट स्टेट बाय फोर्सेस इम्प्रेस्ड अपॉन इट. ठीक है. नाउ let us take one examples which has been given in your book. Now I'm having 2 points. One is O. O is the observer and P is an object. Okay. So P is an object. It's a object which is at rest with respect to O. अभी रेस्ट और रेस्ट का भी पोजीशन, अभी वैसे अर्थ तो गोल घूम रहा है बट अर्थ में जो ममीज है तो वो रेस्ट में, अर्थ के विथ रिस्पेक्ट वो रेस्ट में. बट अगर वो सन को रिवॉल्व करता है तो उससे कैलकुलेट करेंगे तो वो भी मोशन में है. ठीक है. नाउ सो हियर इन दिस केस एज आई सेड दिस इज एट रेस्ट, दिस इज अ पी पॉइंट विच इज एट रेस्ट विथ रेस्पेक्ट टू ओ. नाउ आई एम हैविंग वन मोर पॉइंट ओ डैश. नाउ व्हाट हैपेंस? ओ स्टार्टेड मूविंग टुवर्ड्स दिस वे. ठीक है. एंड आई हैव वन मोर ऑब्जर्वर O dash. So I had O at rest, O dash. O dash is accelerating with respect to O. It is moving this way with respect to O. So in this case, what happens? O comes out to be the inertial frames of reference because it is at rest, and the O dash comes out to be the non-inertial frames of reference because it is at motion. So this comes out to be inertial observer and this comes out to be the non-inertial observer. ठीक है. Now So, how to define this term? As I said, the inertial and non-inertial observer concepts. So for that, see this. If two observers are inertial with respect to one another when they are at rest or in uniform motion with respect to one another, if an observer has an acceleration with respect to another, then they are non-inertial with respect to one another. Getting? So that's it. This is what we have to learn in Newton's first law. So first, Newton's first law states that the object should be at rest. It should be at rest or it should be at uniform motion, and the object, if it is moving from the rest or from a uniform motion, then the law which is being used, that is a Newton's first law. We are going to start with our next law, that is Newton's second law. So let us first define what is momentum. Oh, what a beautiful flower. Now, oh, what is this? A ball. Now what are these? Now here in this part, if I throw a flower on a person, and if I throw a ball on a person, which one will hit the person? Ball or a flower? Obviously the ball. So in this case, so I have to start with a topic called momentum. So that's the thing which a momentum says. Momentum says that the value, so momentum with which the object will hit you, it depends upon its mass and its velocity. सिंपल वर्ड है कि हमें कोई भी ऑब्जेक्ट लगता है, मतलब वो हिट होता है, तो हिट होना किस पे डिपेंड होता है? उसकी मोमेंटम पे. तो मोमेंटम हम किस तरह से कैलकुलेट करते हैं? वो उसके लिए दो क्वांटिटीज लगते हैं. एक होता है मास और दूसरा होता है वेलोसिटी. तो उस ऑब्जेक्ट का जो मास है और उसकी जो वेलोसिटी है, किस वेलोसिटी से उसे फेंका गया है, सो उससे हम लोग उस चीज का मोमेंटम निकालते हैं. सो अभी का जो टॉपिक हम लोग ने स्टार्ट किया था मोमेंटम इज व्हाट? इट्स अ प्रोडक्ट ऑफ मास एंड वेलोसिटी, एंड वी कॉल दिस थिंग एज अ linear momentum. So linear we have said because we are throwing the ball or the flower in a straight line. So the definition which I said, the momentum is the product of mass and velocity is known as the momentum. And mathematically the symbol for linear momentum is P, and P is equals to m. M means mass and V is the velocity. Fine. And as we see, the momentum is the vector quantity. And if you want to write the SI unit, it will be mass means kg and this is velocity means meter per second. So it is kg meter per second. That will be the SI unit for the momentum. So I think the momentum is clear. So what the momentum is? Momentum is defined as a product of mass into velocity, which we are going to use in our next topic. That's in the Newton's second law only. Yeah? So as you can see, the definition of Newton's second law, it says that the change of motion of an object is proportional to the force impressed and is made in the direction of the straight line at which the force is being impressed. So you can say the momentum here, whatever we have defined here, we can mathematically write it here. So what here? The change in motion, F, force, is directly proportional to the rate of change of momentum with time. This is a definition for the Newton's second law. So what does Newton's second law say? In simple word, Newton's second law states that it is the rate of change of momentum with respect to time. So here, so Newton's second law states that the states the rate of change of momentum with respect to time. Or you can also write this: the change of motion of an object is proportional to the force impressed and is made in the direction of a straight line in which the force is being impressed. Now this is a definition for the Newton's second law. Okay, so I have given you the examples of flowers and the ball. So here in this case, mathematically, how I can express this Newton's second law is the change by the change of motion. Newton's mean the rate of change of momentum with time. So mathematically F ये डायरेक्टली प्रोपोर्शनल जैसा है, अल्फा जैसा है, इसको डायरेक्टली प्रोपोर्शनल बोलते हैं, डायरेक्टली प्रोपोर्शनल साइन है. डी बाई डी टी ऑफ पी, पी तो किसका सिंबल है? मोमेंटम का. ठीक है, अभी ये डायरेक्टली प्रोपोर्शनल साइन जब भी आता है तो हमारे पास में कोई तो कांस्टेंट टर्म आता है. तो इस केस के लिए हम लोग कांस्टेंट टर्म को लेते हैं के एंड डी बाई डी टी ऑफ पी. ठीक है, सो एफ इज आवर फोर्स, के इज सम कांस्टेंट एंड पी इज आवर momentum and d by dt is to show you the rate of change with time. So it is rate of change of momentum with time. ठीक है, now p means mv. p मतलब mv है ना. मोमेंटम का वैल्यू क्या है? मास इनटू वेलोसिटी, जो हम लोग ने पहले वाले टॉपिक्स में पढ़ा था. सो वो अभी हम लोग यहाँ पे सब्सटीट्यूट करेंगे. सो dp by dt is equals to d by dt m into v. ये m जो है वो कांस्टेंट होगा तो m को बाहर निकालो, तो ये क्या बनता है? dv by dt. और dv by dt ये क्या चीज है? ये वाला जो क्वांटिटी वो है, ये वाला हम लोगों ने फर्स्ट चैप्टर में पढ़ा है. फर्स्ट चैप्टर में dv by dt क्या बताया था? एक्सेलरेशन. सो डेरिवेटिव इट्स विथ रिस्पेक्ट टू वेलोसिटी. सो dv by dt is what? Acceleration. So the rate of change of velocity with respect to time, we call it as an acceleration. तो अभी हम लोगों ने यहाँ से जो एक्सप्रेशन लिखना स्टार्ट किया था, जिसमें हम लोगों ने p को सब्स्टिट्यूट किया m और v से, और mv से हमें मिला है m into a. So what we can say that f is equals to ma. So we are getting our values. F is equals to k into ma. So what it is? A is equals to dv by dt. It's an acceleration of a body. So what we are getting is F is equals to kma. So you can say that our Newton's second law's formula is F is equals to kma, or you can say at is F is equals to ma. Done with this. So it's clear with the definition. So we have completed with the definition for the Newton's second law. This is also the other way you can write the definition for the Newton's second law. How mathematically you can write it, and how this proportionality sign we have replaced it with k, and how we are writing this whole thing dp by dt, and we are getting it as mv is equals to m dv by dt. So we are getting ma, and then last not the least F is equals to kma, and we are getting F is equals to ma. That's it. So the Newton's second law is equals to F is equals to ma. Now what is this? This is a racket and this is a ball. The ball is being hit by a racket. So here in this case, if I'll substitute k as 1, k as 1, so this expression F is equals to dp by dt. Okay, that you can write it as simply F is equals to ma. Done with this. Now if I want to write this expression in terms of position vectors, so how I will write? We know the velocity is dr by dt. So m dv by dt is equals to, so we are substituting v is what? Dr by dt. So m d by dt into dr by dt. So this whole term you can write it as F is equals to m d square r by dt square. So the force in differential form, it could be written it like this. This is just an example which shows that the plane, a person who is driving a plane, so it doesn't have only one type of force. It can have n number of forces on this. So in this case, we are having three forces which are being acting on this jet. So the one which is coming down, this is the gravitational force. Then we are having the one force that is Fe. So that is a force of the jet, and the Fa, the thrust of the Fa, it's a force of the air. This is a force of the air which we are going to start with the Newton's third law. So what is Newton's third law? See the example. There is a gun, and this